That's a new session started. Okay. All right, the new session started. So welcome everyone to this new session here. I have there is the sort of assistant chair is Professor Atakon. I think Professor Atakon, you're here, right? Sort of.
Yes, I'm here. I'm here.
All right. Okay.
It's nice to meet you.
Okay. Nice meeting you. Thank you very much. All right. So, the first, let me check the first. Should we start with the keynote or we start with paper number 5? Should we start keynote?
Yes, please.
Okay. All right. So the keynote, how long will it take? Professor Fung, like you are muted, so people are muted.
Half an hour, yes.
Half an hour. Okay. So there is
25 minutes presentation and 5 minutes is question and answer and change room. So you manage this way.
Okay, I'll try to.
Yeah. So Professor Feng, I think keynote speech would possibly be like what, half an hour or something, right? All right. Okay. All right, Professor Feng. So, your talk is on phase changing material, right?
Yes.
Magnificent. Okay. So go
okay,
for
I can
it.
share my screen. Yeah. Okay.
All right. Okay. You can start. No problem. Thank you.
Can you see it?
Yes, we can see that.
Okay. I start my talk. Nice to meet you all via the online conference. And my name is Dai Li Feng from University of Science and Technology, Beijing. And today my talk is about research on improving the thermal properties of pore-based shape-stabilized phase change materials. It covers 5 parts. First one, a brief introduction about the research background, and the main part includes 4 kinds of different porous skeletons filled with the same phase change material pack that is because easy for comparison, and end up with a very short conclusion. Under the goal of carbon neutrality, the world is accelerating to increase the proportion of renewables in total energy consumption. The thermal energy storage plays an important role in deepening the new energy storage strategy. According to the Ground View reports, the global thermal energy storage market was $4.8 billion in 2020. And among them, the latent heat storage marked in blue, which is based on phase change materials, contributes a lot. Besides, the phase change materials continues to expand its application field, and it's estimated that the market revenue will reach nearly $700 million in 2028. Thermal energy storage based on phase change materials is the use of the reversible isothermal phase change process accompanied by a large number of heat release or absorb to solve the mismatch and ununiformity between the supply and demand in time, space, or intensity. The utilization of PCMs is to realize 2 functions. One is the energy random input and continuous output, just to feed for the new energy. Another one is the accurate temperature control. Tracing the PCM's development originate from the pure inorganic or organic materials. In order to overcome the leakage and corrosion problems, we have to pack it. There are 2 effective ways to pack the PCMs. One is micro-encapsulation, that we use a organic shell to pack the PCMs. It could maintain the structure integrity and also the stability. And it could be used in thermal protection, smartware, and other fields that with a restrict requirements in leakage problems. Another way is to use porous materials, absorb and immobilize the phase change materials. In that case, we could use a better property skeletons to realize the improvement of the whole composite, such as the heat transfer and mechanism properties could be improved by the skeleton. In a word, the development of new kind of PCMs is to elevate the contradiction between the heat storage and heat transfer. In fact, when we talk about the development of the shape-stabilized phase change materials, is in fact the evolution of the porous framework. From this chart, we could see the research interest on porous materials take steps from the micropores to mesopores until now to micropores. Meanwhile, at each stage is a progress from disordered pores arrangement to ordered one. Our research has carried out a series works with the nanoporous composite PCMs. Many include the typical skeletons and filled with a commonly used phase change materials such as polymers, sugar alcohol, salt, and so on. Based on this research, we have made a relatively clear understanding about the advantages and the existing problems with various skeletons, such as the mesoporous silicon. It's very easy to prepare and low cost, has good thermal stability, but the low specific surface area really restrict the loading of PCM. Then we turn to a metal organic framework or covalent framework, which has a smaller pore size, result in a large loading of the PCM, but it's very difficult to sneeze and have a cost too much. And the thermal conductivity and thermal stability is also very poor. And relatively speaking, we think the carbon skeletons has a greater performance, both in an excellent compatibility and also as it's a carbon material. So we think it has a relatively higher thermal conductivity. And very recently, we are interested in the biomass derived skeletons because the raw materials are very easy to access and environmental friendly, low cost. So today, my talk will focus on this part. Yeah, if time permits, I will also show some initial results about the biomass derived skeleton. Okay. First, we choose mesoporous carbon FDU15 with two-dimensional hexagonal structures, and it has a digestible pore diameter ranging from 2 to 10 nanometers. And the phase change material is polyethylene glycol, PEG. Yeah, it has good thermochemical properties and good fluidity. And we also could realize a controllable melting point by adjusting the repeating unit of the molecular chains. At first, the PEG was introduced into the mesoporous carbon via a commonly used melting impregnation method. Due to the good fluidity of the melted PEG and the strong capillary force of mesoporous carbon, the composite reached a maximum loading of 75 weight%. Meanwhile, we also extracted the structural parameters of both mesoporous carbon and crystal PEG to build a molecular model for further simulation and analysis. Then we use DAC to test the melting point, freezing point, and also the latent heat. We can see from this figure that our prepared sample shows the highest latent heat value comparing with other nanopore-based counterparts. And the supercooling, as we know, it also drawbacks that limits the application of PCMs. And after compounding, we see the supercooling was reduced from 33 degrees C of the pure PEG to less than 20 degrees C. Okay, this is a common advantages caused by the skeleton introduction, because the huge specific surface area of the skeleton could provide large number of nucleosides for the PEG to crystallize. We also introduced 3 indicators to evaluate the heat storage and release performance of these new kinds of material: crystallization ratio, reflects the effect of the confined space on crystallization, and the encapsulation ratio represents the latent heat loss caused by the skeleton, and the heat storage efficiency also represents the influence of skeleton on crystallization during the thermal cycling. So we can see that both of the ratio and efficiency are greater than 70%, which is also better than other counterparts. However, the measured latent heat enthalpy is always lower than theoretical value, which means the crystallization ratio is always less than 100%. This is caused by the host-gas interaction between the skeleton and the peg. This interaction caused a wall attachment effect, which means the peg chains were attached on the wall surface, and this part of the chains could failed to carry out a phase change, so that this is responsible for the loss of latent heat. Then we use the MD simulation to relieve the crystallization and the heating process. Just as the video shows, we can see during the cooling process, the polymers preferentially attach to the wall surface and then began to crystals. And the crystallization gradually expanded inward from the boundary, then appears a crystallization layer near the wall. And let's look at the heating process. With the temperature increase, the crystal in the core area is first destroyed. Then it diffused to the layer, to the wall. But even at 800 Kelvin, which is greatly higher than the melting point, the layer near the wall keeps crystalline. This means this part of peg could not phase change. We also use the laser flash to measure the thermal conductivity of the composite. We can see it has a 63% increase than the pure peg, just because it has a better match between the skeleton and the peg after compounding. So have a short summary that our previous work mainly focused on a single-scaled nanopore skeleton packed with phase change materials, though we have realized a better performance such as FDU does, but it still could not realize a significant increase just because the single-scaled pores have limitations on the improvement. For example, the nanoscale pores could supply a strong capillary force and bond the PCM firmly within the pores, but the too small pore volume results in a very low loading of the PCM and also caused a very strong attachment effect that results in the loss of thermal storage density. And for micropores, it could provide the pore volume so that could pack more PCMs, but it has weak capillary force so that the PCM is very easy to leak out. Our idea is to build a hierarchical structure, which means we could merge the advantages of both the big pores and small pores that bring some innovation breakthroughs and also broaden the choice of the PCMs. So first, we need to obtain the hierarchical structure carbon. We used the direct carbonization method to obtain the hierarchical porous carbon that from the Metal Organic Framework 5. During the carbonization, we can see the pores at different scales was generated. For pores less than 2 nanometers was originated from the parent MOF5. For pores from 2 to 7 nanometers is formed by the migration and aggregation of small zinc oxide grains, and for pores larger than 7 nanometers, just formed by the evaporation of larger zinc oxide grains. And from SEM, we also can see there exists micropores, which is about 1 micrometers. And the TM shows it also possesses mesopores, is about 10 nanometers. The nitrogen absorption desorption curves also shows the micropores mainly concentrate on the 0.5 nanometers, and for mesopores is mainly concentrates on 1.6 and 4 nanometers. This is our model basis. Yeah, we based on this data to build our MD simulation model. And the specific surface area and pore volume are greatly increased comparing with that of the FDU15. Okay, here is the simulation model, and also we verified the pore volume and specify specific surface with the experimental value to verify our model. Then we use MD to simulate the absorption of PEG into the pores. At first, the PEG first attracted into the large pores, and then it was absorbed from the large pores into the small pores. From the radial distribution function, we also find that the force between the skeleton and the PEG was stronger in small pores. This could realize our design idea, that large pores could provide more space to ensure a high loading of the PCM, and for small pores, it could supply a strong capillary force that firmly bind the PCM so that prevent it to leak out. More than our expectation, the maximum loading of this hierarchical porous carbon could realize 92.5 weight%, greatly improved comparing with FDU15. And the corresponding latent heat is nearly 113. And it also shows a good thermal stability, that after 15 times thermal cycles, the latent heat loss is only 2%. So we can conclude, based on the hierarchical structure, the composite achieves both of the high loading and high heat storage density. And the supercooling is further reduced because comparing with the single pore composites, because it could supply an even larger specific surface area that is conducive to the crystallization of the PEG. And for the ratios, both of the encapsulation efficiency and the crystallization ratio, both of them are greater than 90% or nearly 90%. Comparing with FDU, those for FDU15 is only 70%. And the thermal conductivity is slightly enhanced after compounding. So we have a comparison between the FDU15, which has a single-scaled nanopore structure, and with the hierarchical pore structure. For loading, maximum loading was from 75 to 93%. And the corresponding latent heat was improved by nearly 60%. But due to the high porosity of the hierarchical structure, the thermal conductivity decreased. So next, we thought how to realize a simultaneously improve in both the thermal conductivity and the energy storage density. Then we sort the nano additives, such as carbon nanotubes, which has a relatively higher thermal conductivity. And we composite these two, the CNTs, into the graphene foam ultrasonic method, and then we obtained the GCNT as a porous material, and then we load PEG into the porous material. It's worth mentioning that before this preparation, we also tried an ordinary way. That is, we put the CNT into the PEG first, then the PCNT was absorbed into the graphene foams. But we also tested the thermal properties of this kind of composites. It shows I should say it's not bad, but not as good as I want. And from the SEM, we can see the CNT successfully entered the graphene foams and constructed the pore structure with different scales, just from nanometers to microscale meters. And the PEG could be successfully absorbed into this framework and achieve a maximum loading of 88%. From the pore size distribution, we can see before introduce of CNT, the graphene film is mainly distributed at 2 or 3 nanometers. But after adding CNT, the pore distribution in the range is concentrated in the range of 15 nanometers and 25 nanometers. That means the carbon nanotubes breaches in the graphene macropores that form a secondary framework. From the specific surface area and pore volume, we can see that after addition of carbon nanotubes, the pore volume is not significantly dropped because the CNT is characterized with the hollow structure, and the PEG also could enter in the hollow of the CNT. Thus ensures a high loading. And we can see at the maximum loading, it almost full under the pore volume is almost full under the maximum loading. And the corresponding latent heat and crystallinity is the highest comparing with the above mentioned 2 kinds of material system. And what's more, the thermal conductivity of the PEG GCNT is also increased significantly. Yeah, comparing with the pure PEG, it increased 1.5 times. Hierarchical structure is one of the most typical characteristics for biological materials, and due to the hierarchical structures, it endorses the organisms some unexpected properties. This gives us a hint that why not use a biomass as a template and prepare the hierarchical carbon via a direct carbonization method. Of course, the advantage is it's green and renewable, and also biodegradable, and also low cost. And this is a very rough prediction, rough estimation about the preparation price. Okay, we can see that for the biomass derived materials, it has a really low price comparing with the previous ones. And in the experiment, we tried the pine, bamboo, and also the rice. Via a direct carbonization, we obtained the carbonized rice. And interestingly, the latent heat of the carbonized rice-packed PCMs is higher than those of the MOFs-derived hierarchical porous carbon. Yes, and the supercooling is even lower than that of the previous mentioned materials. And besides, we characterize it with infrared thermographic images that the after compounding, it could accelerate the thermal response. And the carbonized rice also increased the solar photothermal energy conservation, that it exhibits a much better light absorption capacity and can more effectively capture the sunlight. And we also calculate the solar photothermal conversion efficiency for the composite could reach nearly 55%, comparing with the pure PEG that only 0. So let's come to a short conclusion. We select 4 kinds of skeletons, range from the single pores FDU15 to a hierarchical structured HPC, GCNT, and also carbonized rice. We could realize a great increase in both of the heat storage, prop density, and also the thermal conductivity. Okay, thank you very much for the funds and also the hard work of my students, and thank you all.
Magnificent work, Professor Feng. Very, very nice indeed. Okay, so just ask the audience if they have questions, please. If people raise their hands, will I be able to see this here? Because any questions? I cannot see hands being raised on my screen, so any questions at all? Okay, so maybe
yeah,
I
have
just
one, EB.
Okay, magnificent.
Yeah.
Thank you.
Nice presentation, Dr. Fan.
Thank you.
Oh, I turn my camera on. In the last couple of slides, you talk about using the natural materials. So how do you control the pore size of the natural material, because it can be randomly distributed?
Yes, we can. We cannot control the pore distribution. Yeah, so we have tried many biomass. Yeah, such as pine, bamboo, and rice. Okay, but I just show the result of the rice, carbonized rice, because it's the best performance among this. Yeah, so just try. Yeah, we don't have any way to control the pore range. Yeah, this is also very a big problems for this.
Yep. Thank you.
That's a nice mechanical engineering question, Dr. Tron.
Exactly. Thank you. Back to you.
I was always thinking about that because Professor Fong, you spoke about the force between the host material and the PCM. I think. So how do you measure this adhesive force or whatever?
You mean measure the properties?
Yes, exactly. Specifically because you mentioned the force and I'm mechanical engineer. So
maybe the main properties we concerned about is latent heat and melting point and freezing point, and this could be tested by differential scanning thermometers, DSC. Yeah, we call it DSC. And for thermal conductivity, we always use a laser flash method. Method because the sample is powder, and very small, other method is hard to realize the measurement.
Exactly. Are you well supported, like with in terms of funds and stuff for this project? It's very nice work, but I can feel it has to be really supported properly.
Yeah, thank you.
So have you got a number of grants and things to do this, or?
Of course, yeah, of course. Most of them from the NSFC, National Nature Science Foundation of China.
Yes, that's magnificent work. So what the best application for this? Where because I have maybe a couple of minutes, so I want to use those 2 minutes to get some information from yourself. Please.
Yes, I think it's still far away from the application because just as I show, the price is quite high.
Yeah, this was my exactly. I had questions about the cost.
Very hard to get a large amount of the material. Only in experiments.
Yes,
very
L experiments. Any questions from the audience at all? Firoz, you have a question? No? Okay, so maybe no questions. So thanks very much, Professor Fong. This is a very enjoyable presentation.
Thank you very much.
Great job, very impressive work. Thank you. Okay. Thank you. So now, possibly now we'll move to the next one. Let me see on my list. Okay, thank you. Next presenter is, this is Dr. Sukan, Natenda Sukan, right? So this is submission number 5, overview of machine learning application to battery thermal management systems in electric vehicles. So that's an electric vehicle topic. This should be really interesting as well.
I'm here, guys.
All right.
Hello, guys. Let me share my screen, please.
Yes, magnificent. So we'll have possibly 10 minutes for presentations and maybe a couple of minutes for questions or something to be able to finish on time. Is this okay?
Okay.
10 minutes. Okay.
Do you see my screen?
Okay, all right. I can see your screen clearly. Yeah, magnificent.
Okay.
Okay, my lady, go for it.
My name is. Good afternoon, everyone. My name is Natila Sukam. I am a master degree student in mechanical engineering from Chiang Mai University. Today, I will present you on overview of machine learning applications to battery thermal management systems in electric vehicles. Here, I would like to start with sustainable development. It is a modern concept of organizing human needs without undermining the integrity and stability of natural systems. The sustainable development covers all aspects of environmental, social, and economic. Transportation is also linked with the sustainable development. Currently, the transportation mainly consumes energy from fossil fuels and becomes one of the largest air pollution sources. To protect our environment, reducing the use of fossil fuels in transportation may possibly play a key role. In general, there are 4 types of electric vehicle or EVs: hybrid, plug-in hybrid, battery, and fuel cell EVs. Hybrid EV consists of an electric motor consuming electricity from batteries and an ICE getting energy from petroleum-based fuels. Plug-in hybrid EV is a combination of electric motor and ICE, but its battery can be recharged from other outlet electricity, such as charging stations. Battery EV runs entirely by an electric drivetrain powered from a large battery pack, which is plugged in charging from an electrical grid. Fuel cell EV is considered to be a zero-emission vehicle. It uses a fuel cell technology that is an energy conversion from chemicals to electricity. The main components of EVs are: an energy storage system is an energy supply when driving, heating, cooling, and running all accessories. A thermal system is a temperature controller from the battery system. It is applied to prevent the battery from overheating when recharging and discharging. An electric motor transforms electrical energy to mechanical power driving the vehicle. A charging system is used to avoid damage in battery or electrical circuits when connecting electrical current into a battery storage system. An electronic controller is to operate between battery and motor to control the speed and acceleration of EVs. Battery Thermal Management System, or Btms, is a technique used to optimize battery temperature, which will improve the performance of EVs. The objective of this paper was to present an overview of Btms in EV development, including applications of machine learning techniques to optimize Btms performance, and Btms for topical environmental conditions. Battery plays key role in powering and driving EV. It has been developed for many more types. Lead battery. Lead acid battery is the most common type of battery used in typical automotive vehicles. It is rather cheap and its manufacturing is simple. Nickel battery, a nickel cadmium and nickel metal hydride battery appears to be popular nowadays, but this battery type is costly rather than a lead acid battery, and it comes with a memory effect. Lithium battery, a lithium-ion battery is the most popular for being used in EVs. Lithium-ion batteries do not suffer from the memory effect, while have a very high energy density and quite long life cycles, although it needs a time of recharging. As I mentioned before, Btms is specially designed for controlling battery temperatures. Btms is expected to be able to remove heat from the battery, optimize the battery temperature, and ventilate hazardous gas from battery. There are 6 types of Btms including air cooling, liquid cooling, direct refrigerant cooling, phase change material cooling, thermoelectric cooling, and heat pipe cooling. For air cooling, this system uses air as medium in thermal management. The intake air can be either from the environment or from the cabin and can be conditioned by heat or evaporator. It can be also be an active or passive system as shown in figure A and B, but the active system needs an external power source. We can also get back the heat to the system as shown in figure C. For liquid cooling, this system applies liquid at heat transfer fluid. The system is presented in figure D and E. 2 groups of liquids that are generally used. The first one is a dielectric or direct contact liquid. The second one is a conductive or indirect contact liquid. The indirect contact system appears to have better isolation and being much safer for the contact of battery modules and surroundings. Direct refrigerant cooling shown in figure F. It consists of an air conditioning evaporator that directly uses refrigerant as a heat transfer fluid, circulating to the battery pack. The advantage of this type is more compact in design and less weight. It can effectively absorb a large amount of heat while maintaining the same temperature. Phase change material cooling or PCM is presented in figure G. It works by that generated heat is absorbed by the material phase change, so the temperature of the module is fixed at the melting point until the latent heat reaches the maximum. Typically, this technique is used as the conductor and buffer in Btms. Thermoelectric cooling. The thermoelectric set can be seen in figure H. For EVs, the heat is converted by the electric input. Thermoelectric cooling has many advantages over others, such as small size, lighter weight, higher reliability, and more easy to do cooling and heating. Nevertheless, its limitation is costly and poor energy efficiency. Lastly, heat pipe cooling. A heat pipe cooling shown in figure I is another way that can be used to upgrade a passive air system. Heat pipe cooling reduces thermal resistance by 20 to 30%. Compared to a thermoelectric system, the heat pipe is more reliable because there are no moving parts and no energy consumption. Next, I am mentioning to the application of machine learning on Btms. In general, the lithium battery performance is directly related to its temperature, which is mainly generated during recharge cycles, and it effectively works in a narrow range of temperatures. However, at the present, fast charging technology is being developed markedly. It is expected to increase and expand market of lithium batteries. The technology is based on the optimization of maximum charging speed and safety. Attia and co-worker proposed an application of machine learning on developing a closed-loop optimization of fast charging protocols for batteries, in which two key elements were integrated into consideration. One is machine learning with Gaussian process regression algorithm was applied to build an early prediction model for predicting a final cycle life of batteries. Two is a Bayesian optimization algorithm was employed to efficiently determine the parameter space of fast charging protocols. It can reduce the number of experiments for fast charging battery protocols. Machine learning can be used to efficiently optimize the space of parameters, specifying the current and one-step profile of 6-step 10-min fast charging protocols, while also maximizing battery cycle life. For tropical environments like Thailand, National Metal and Materials Technology Center and National Science and Technology Development Agency proposed two prototypes of Btms. The first one, a cooling system, used water coolant from the radiator. The second one, used refrigerant from an air conditioning system to directly cool down battery modules. Both prototypes can be used to control battery temperature up to 40 degrees Celsius. However, the first prototype had a slower response when the battery temperature rapidly rises. This was because the heat transfer in this prototype was from sensible heat mechanism. A leakage of water may cause a short circuit of electricity. The second prototype was less complicated. It was very responsive and the heat transfer was from the latent heat mechanism. A short circuit in a battery pack cannot occur from the leakage solution. However, this system was difficult to control temperature differences of our battery cells to be within 5 degrees Celsius, caused by refrigerant has a very heat extraction ability. This system also requires more energy than the first one. In another view, even if there have been some works on applying machine learning to Btms of EV, very few has considered the specific challenges for tropical climates like in Thailand. Lastly, I think the future prospect of machine learning in Btms that is interesting includes automatic calibration model for Btms, machine learning assisted multi-scale modeling for Btms, machine learning models for thermal and electrical performance prediction of high-capacity lithium-ion battery, and optimized battery temperature control for Btms. In this paper, we can summarize the overview including lithium-ion battery is the most promising battery type for EVs. Btms is important to control the thermal behavior of battery, especially for lithium-ion batteries. 10-min fast charging protocols were successfully developed using machine learning to specify the current and voltage inputs of battery. In tropical environment conditions, the special design of Btms is needed. We wish to thank the National Research Council of Thailand and Chiang Mai University for supporting this paper. And thank you for your attention. Good afternoon, everyone.
Okay. Thank you. Okay, actually, you went possibly a couple of minutes above what's the time allowed. So I'm not sure if we have time for questions. But however, is there a question, please, from the audience? Does anyone want to ask a question about machine learning and when it's applied to battery, like thermal control? Okay.
I have one question to ask, just one simple question. For the tropical countries like Thailand or India or Bangladesh, what can be the design modifications?
I would like to say, in my opinion, in condition of Thailand, like tropical, the temperature range in 40 degrees. And we can cool down the battery as like to preparing temperature, and we can cool down into the range of high rate of and charging and recharging.
Okay. All right. So I think that's enough.
Thank you. Thank you. Yes.
Thank you. Yes. Exactly. Because just in the interest of time more than anything, I had a couple of questions, but I'm not going to ask. I'll just possibly get the next paper now. Dr. Matsura, I think there is. Yeah, exactly. So.
Good afternoon. Thank you very much for chairing this session.
Thank you, sir. Thank you.
Can you see my slides?
Yes. Yep.
Good afternoon, everyone. My name is Kazuo Matsura from Ehime University. Today, I'm going to talk about numerical prediction of the region of high energy dissipation for different free stream turbines in transitional low pressure turbine cascade flows. In this presentation, in this study, first I explained the research backgrounds and objectives. Then we'll talk about the computational methods. And after that, I will do the cascade flow computations with different free stream turbines under dynamic rotor stator interactions. And there, I will investigate the distribution of energy dissipation function, which is an indicator of loss of turbine regarding thermal efficiency. And finally, I will summarize my presentation. Low pressure turbine in aeronautical engine occupy 1/3 of the total engine weight. Is a very huge component. This part is low pressure turbine is a very huge component, and so by increasing the performance of the low pressure turbine, by increasing aerodynamic loadings of the turbine, we want to decrease the weight of the low pressure turbine. On the other hand, it is related to the problem of the boundary layers of the low pressure turbine, and the boundary layer is affected by the Reynolds number of the low pressure turbine blade is 10 to the 4th and 10 to the 5th, and it's a very low Reynolds number, and the boundary layer is likely to separate. On the other hand, the boundary layer is susceptible, is affected by the free stream turbulence or wakes from upstream blade rods. And so the boundary layers are become transitional in addition to the tendency of separation. And if the separation takes place, a huge separation takes place, the huge loss will be produced at low pressure turbine, and the transition prevents such huge separation, and a transition prevent a huge loss. So the competition becomes important. The competition between the separation and boundary layer transition. And in the designing a low pressure turbine, we need to control this competition. And in my previous study, I conducted dynamic rotor stator interaction for a turbine computation, and I conducted a comparison of cases of no free stream turbulence and isotropic free stream turbulence of 5% and wakes from an upstream cylinder. And I found that free-stream turbines creatively affect the global pressure fluctuation, which become a medium to convey boundary layer information away from the cascade. However, regarding the loss, regarding energy dissipation, I did not investigate the situation. So in this study, I want to investigate the effects of various free-stream turbulence, free-stream disturbances on energy dissipation in compressible transitional flows of low-pressure turbine cascade under dynamic rotor-stator interaction. Here, I will explain the computational methods. The governing equations are fully compressible Navier-Stokes equations, and a higher order finite difference method is used for the computation. Space discretization is 6th order compact scheme, and the stabilization, the 10th order compact filtering. And the equation is solved in time by a 3rd order Runge-Kutta method. And perfect gas equation is used to close the system of equations. Sorry, I can't go to the next slide. Just a moment, please. Sorry.
No worries, no worries.
Okay. Here I will explain the inflow turbines generation. At the inlet, in some cases, at the inlet of the stator, I introduced free-stream turbulence. And here I will describe the generation method of numerical turbulence. And first, I generated, I seeded random numbers on the flow fields, which follows the target energy spectrum, Tarman spectrum. And after running Navier-Stokes simulations of isotropic turbulence, and I extracted series planar information from the flow field, and I injected, depending on time, I injected this cross-sectional turbulence information to the cascade computation. Sorry, it doesn't move. So
no problem. No worries. Take your time. Don't worry.
Just a moment, please. Sorry.
Okay, no problem.
Can you see my slide? Yes, and I will talk about the cascade flow computation with different free-stream turbulence and the dynamic rotor-stator interaction. The target cascade is T106. The Mach number regarding design point condition, Mach number is around 0.59, and the isentropic outlet Reynolds number is 5 multiplied by 10 to the 5th, and the chord length is around 10 centimeters. And I do the dynamic rotor stator rotor interactions in this study, and the stator is modeled as by a cylinder, and the whole computation domain consists of a cylinder region and the blade region, and the blade region moves relative to the cylinder region. And regarding the mesh, H topology mesh is generated within the cascade. Here, I'm showing the computational cases. 3 cases are considered in total. In case A, the rotor speed is 20 meter per second. Strohal number, which is computed from the blade passing frequency multiplied by chord length divided by the inlet velocity at the nozzle inlet, is 0.264. And regarding free-stream turbulence, only cylinder wake from the cylinder is considered for the rotor passage, and no free-stream turbulence is considered in this case. In case B, the speed of the rotor movement is 60 meters per second, and Strohal number is much bigger than the case A, and 0.792. And regarding the free-stream turbulence, and only cylinder wake is considered. In case C, the speed of rotor movement is 60 meters per second, and Strohal number is the same as the case B. And the free-stream, regarding free-stream turbulence, cylinder wake and 6% isotropic turbulence is introduced at the inlet of the stator. Because there is an interface between the cylinder region and the rotor region, and I developed a new method for treating the interface problem in this dynamic stator rotor interaction, based on the interface method proposed previously regarding the situation of conforming at the interface. I extended this method to the non-conforming situation appearing in this study. In this interface method, the variables on the interface is updated based on the characteristic lines from both sides, and the variables are averaged. And in order to cope with non-conforming situation, a Lagrange interpolation is used to interpolate the variables for the downstream and from the for the domains considered. Regarding the variable, here I am showing the results. The effects of varying the rotor speed and inflow disturbance of the cascade flow fields. In case A, because a Strohal number is smaller, wake trajectory is inclined and almost parallel to the bladed cascades. Only one end of the trajectory impinge on the pressure side. And in other timing, the trajectory go through the cascade parallelly to the cascade due to the small Strohal number. And because the trajectory does not touch with, does not break the boundary layers on the suction side and near the trading edge, separated flow vortices, span-wise vortices are observed. In case B, a trajectory becomes much more orthogonal to the blades due to the higher Strohal number, and the two sides of the trajectory impinge on the pressure side and the suction side, and there the trajectory introduce disturbances inside the boundary layers on both surfaces. And after the impingement, turbulence is produced, and when the disturbances is injected on the suction side, trading the vortices, separated flow vortices are disturbed, and this organization of boundary layer takes place near the trading edge. In case C, because there is a fine
Dr. Matsura, sorry, just to stop you for a second. Like, do you have more slides, or this is the last one?
Yes.
Because it's, you have gone past, I think, the time by far. Okay. So maybe people want to ask questions. What do you think? Yep.
Okay. This is my final slide.
Okay. All right. So you can talk about this one, and possibly we can give people a chance to ask one question if they wanted. Is it okay? All right. Yes. No, sorry. If that's all right. Okay.
No, no problem. I estimated, computed energy dissipation on entropy generation, and I divided the whole domain into 8 sections and got the energy dissipation in each domain, and found that section side location and trading near the trading edge locations and the wakes regions are main sources of loss, and found that approximately 70% loss occupies are produced in section side boundary layers, and a few percent can vary depending on the type of space-time perturbation by the free stream turbulence. Thank you.
Very thoughtful, very nice work, really, indeed. I hope I had more time to watch everything. Okay, any questions, please? Any questions on turbine performance? All right, okay, because of the time, maybe I'll just move to the next presentation, which is paper 53. Mr. Akapan?
Yeah, me.
Thank you very much.
Okay, thank you.
Few seconds.
All right. When you start, I'll just start
Thank
my.
you very much for letting me presentation.
All right, you can go for it if you're ready.
Okay.
Yep, we can see the slides. Yep.
Good afternoon, everyone. My name is Tidul Akapan. I am a master's degree student in electrical engineering at Chiang University. Today, I would like to present my research in the title Optimal Real-Time Operation of Battery Energy Storage System for Reducing On-Load Changer Operation of Substation Transformer. Nowadays, most countries tend to increase electricity generation from renewable energy. So the distributed generation using renewable energy resources become an important part of the electricity generation system in the future. However, the power generated from renewable energy sources such as photovoltaic wind turbine can be fluctuated due to random change in climate development or other factors. So this intermittent power output affect the power distribution system, for example, the power quality, voltage stability problems, and voltage variation. The voltage fluctuation can have an effect on the increase on load changer or OLTC operation, which regulate the voltage level in voltage constant. Okay, this increased operation impacts the component lifespan, damage, maintenance cost, and system reliability. There are many techniques proposed in the literature 1 to 5. Each method has different advantages and disadvantages. In the literature 1, 2, and 3, the traditional approach implemented with the smoothing problem of renewable energy sources can reduce the power fluctuation by discharging active power of battery energy storage system, or BESS, to improve the smoothing problem of PV and wind turbine generation. But the proposed approach does not take into account the operation of OLTC related to voltage variation. And in the literature 4 and 5, the optimal BESS can reduce the voltage fluctuation and OLTC operation by the optimal charging, discharging active, and reactive power of BESS. However, This method take into account only PV operation in conjunction with BESS in an offline control. This proposed strategy are not fully integrated with renewable energy sources and cannot be processed in real time. Next, this slide will talk about the objective of this research. It can be concluded that the smoothing problems of PV and wind turbine affects and increase in the OLTC operation and of substation transformer. Therefore, the optimal real time of BESS is proposed to reduce the excessive OLTC operation and also mitigate voltage fluctuation in all days. And the resulting output which solve the excessive OLTC operation issue shows the charging, discharging of BESS operation. This slide, the traditional OLTC operation, the OLTC have to set 3 requirements. The first, nominal voltage set point. Second, bandwidth. The tap should not operate in this band. And the third, time delay to the tap movement under the temporary voltage change. In this research, the optimal BESS will operate within a time delay of OLTC setting. Charging, discharging the appropriate active and reactive power of BESS will cause modified power flow for mitigating the voltage fluctuation and hold the tap position of OLTC operation. For determining the optimal real time of BESS is formulated as an optimization problem with the objective function to minimize the absolute value of the difference between the previous and the current tap position of OLTC. And the research method, it can be noticed that the voltage fluctuation from the intermittent power output of renewable energy sources is a highly complex problem. So this research will use the optimization technique to find out the optimal operation of BESS according to the objective function. In this research, the optimization problem is solved by the particle swarm optimization or PSO algorithm. Next, the fluctuation in voltage profile occurring in the system is determined from the voltage difference variance value in equation 2 and 3. And this slide, the PSO is designed and developed in MATLAB program by using M5 chip, and the Silent Power Factory program is used to evaluate the load flow and OLTC operation by DPL chip. The combination of both programs can operate seamlessly by using file name switch.csv. This file is used to switch the cooperation of 2 programs to get the best efficiency. Then this slide will talk about the case study of this research. The test distribution system is the IEEE 133 node test feeder with BESS, PV, and wind turbine installation, and it includes 4.16 to 4.16 kilovolt OLTC installed between node 160 and node 67, where it's extremely affected by the intermittent power output from PV and wind turbine. This paper has considered different case studies as follows. In scenario 1, the test system is defined as the base case without BESS installation. In scenario 2, the PV smoothing mode, the BESS overlay is defined as charging, discharging active power for smoothing PV generation. And in scenario 3, the proposed PSO is used to determine the optimal power output of BESS. In one day, the simulation is divided into 15 minutes sampling at 96 durations per day. This slide shows the comparison of tap OLTC operation and the energy uses of BESS of our case study. From the picture on your right hand, you can see that the blue line refers to the base case, the yellow line refers to the case 2, and the purple case shown on the left line. The simulation result shows that the optimal real time of BESS as shown on the left hand It's the most effective method to reduce the number of tap OLTC operations. The number of tap OLTC operations significantly reduced by about 57% when compared with the base case and 50% when compared with case 2. Moreover, the BESS energy usage per day is much less than the previous smoothing mode, about 91% in this test system as shown in the table. This slide shows the comparison of system voltage profile of our case study. From the proposed case, the optimal real time of BESS not only reduced the ORTC operation, but also improved the fluctuation in voltage profile, which are about 60% of the voltage difference variance value when compared with the base case. It indicated that the proposed method not only manage power flow for reducing the ORTC operation, but also control bus voltage to increase system performance. Okay, this slide, this slide, the table shows the processing time result of the proposed case. You can see the maximum time for analyzing the optimal BESS in all duration is about 13 seconds. It's shorter than delay time of OLTC setting in this test system. It means that the optimal BESS can operate within a time delay of OLTC in all duration. It can be concluded that the optimal real time of BESS operation using the proposed phase algorithm can reduce the number of tap OLTC operations and improve the system voltage profile under the intermittent power output from PV and wind supply, and use a small energy usage. For this reason, it may be used the remaining power to cooperate with the auto function of BESS to solve energy management problems, for example, peak shaving, load leveling, and spinning reserve. Thank you for your attention. Do you have any questions?
Excellent work. Very nice. I like that. That's very nice. That's very innovative. Okay, any questions, please? Well, magnificent presentations, like really very nice work.
Thank you. Thank you, sir.
So questions, please, on battery, like energy storage regulation. Questions? All right, so I'll just let this one go then. All right, thank you very much, Kapan.
Sorry.
All right, okay, I cannot see if there is someone raising hand. So is there a question? Just go for it.
I have the short question about
yes, go for it.
Yeah, the type of the battery, does it have effect to this technique or not?
And this question I don't know. This research is not considered in this project. Sorry.
Okay, thank you.
Sorry.
Yes, the battery type is okay. All right, no problem. In terms of timing, that's 10 out of 10. Okay, the next one is Mr. Hong Pan. Yes, you're here. I can see you. Yes. Magnificent. But maybe you're not. Are you muted? I cannot hear what you're saying. So, Hong Pan.
I'm here.
Yeah, magnificent. Okay, ready for the presentation?
Yes.
Okay, sir. Go for it. I like the confidence.
Good afternoon, everyone. My name is Tinwat Hongpan. Today, I will present our paper on H-infinity controller design for efficiency optimization of magnetic bearing in 5-view energy storage system. 5-view energy storage system can respond quickly to energy storage demand by converting energy between electrical and kinetic form, storing it within angular momentum of the 5-view rotor. The advantage of this technology include high power density, low cost per kilowatt, low maintenance requirement, long operating life, and low environmental effect. For their reason, 5-view energy storage has been used in various ways, such as backup power for critical systems, regenerative power for machine and vehicle, and bridging power for renewable energy source. In high-speed 5-view, magnetic bearings are used to suspend the rotor without contact, thereby eliminating energy loss from friction and reducing wear and maintenance requirements. This research studied the feedback controller design for active magnetic bearing in high-speed flywheel by having the target to maintain rotor dynamic stability and minimize power consumption of the AMB. The AMB usually includes 4 electromagnetic actuators which can apply force to the rotor in 2 orthogonal directions. The forces are controlled by regulating the current in the coil of the electromagnet in real time. The forces are varied according to measured position of the rotor. This allows the position of the rotor to be stabilized and also the characteristic of the bearing to be influenced via the feedback control law. The study is based on small-scale prototype system. The system has 5.8 kg steel rotor with diameter 220 mm. The upper and lower AMB are used for controlling rotor position in horizontal plane. A permanent magnet touch bearing supports the rotor to levitate in vertical axis. The system housing is designed for safety and vacuum environment. The components form the rotor dynamic system for controller design. In rotor dynamic model, the equation of motion of the rotor are based on rigid body motion as shown here, where vector Q is rotor center of mass displacement, F is the magnetic force, D is the disturbance force, omega is the rotational speed of the rotor, M is the rotor inertial metric, J is the gyroscopic metric, and E is the force transformation metric. The force from the AMB are dependent on coil current I and rotor displacement Q as shown here, where Ka and Kb are negative stiffness coefficients for upper and lower AMB. Kia and Kib are the AMB force current coefficient. The measured output are the rotor displacement Y. For feedback controller design, the plan includes the AMB and rotor subsystem. For the physical system, the displacement of the rotor are measured by flow gap sensor of inductance type. The signals are sent to PC-based real-time controller, which calculate the required current, and their signals are sent to the AMB drive, which supply the actual current to AMB coil to control the bearing force. For the experiment, the main result involve frequency response measurement, where sine wave excitation is added to the current output from controller, and the rotor harmonic response is observed and measured. This photo shows the main component in experiment setup. You can see the electrical connection to the upper and lower AMB which connect to the flywheel vacuum housing. Current voltage meter are used to measure power consumption for each subsystem. Additional electronic is used for signal conditioning and temperature monitoring. In the experiment, the flywheel rotational frequency was limited to below 50 Hz to ensure safety. When using the conventional proportional derivative control method, two main problems occur. The left graph shows the rotor vibration and the AMB current. When the rotor is spinning at 25 Hz, the rotor vibration is caused by disturbance excitation from the motor and also rotor unbalance. The disturbance produces harmonic component in AMB coil current. Due to a large coil current, the measured power consumption of the AMB is around 4.6 watts in total. The right graph is shows root locus of the system with PD controller for increasing rotational speed. The pole associated with the nutation mode of the rotor become unstable if the rotational frequency is higher than 25 Hz. The difficulty with controlling this mode is because the natural frequency increases with the rotational speed due to the gyroscopic effect, and the influence from the PD controller becomes destabilizing. The H-infinity controller method has been widely used to solve controller design problems involving multi-variable systems. The optimal controller will minimize H-infinity norm of the closed loop system. The controller design requires the definition of two weighting subsystems W1 and W2 which act on the plant output. The plant GPD includes the rotor AMB system and initial PD controller chosen to achieve stable suspension at low speed. Hence, the H-infinity controller will work in parallel with PD controller to improve stability and reduce power consumption of the AMB. The weighting function acting on output y is chosen as a constant diagonal metric W1 in order to limit the peak vibration as measured through output y. The main components of the rotor vibration are found to be harmonic oscillation with frequency equal to 1 time and 3 times of rotor speed. Therefore, the weighting function W2 is chosen to have resonant pole, which will reduce effect of this excitation on the AMB coil current. This should reduce power consumption of the AME by minimizing the coil current during operation. The graph shows the frequency response singular value of the coil loop system for rotational speed 25 Hz. The red line are the inverse of design weighting function which behave as upper bound of the FRF. The left graph confirms the stability of the system for this speed. The right graph shows the AMB current should be very small if disturbance frequency are 1 time omega and 3 times omega as expected. This graph shows the system frequency response obtained in the experiment when the rotational frequency of the rotor is around 25 Hz. The H-infinity controller clearly improved the stability of both the nutation and precision mode of the rotor when compared it with the PD controller. Similar results are obtained when measurements are made at the lower AMB. The graph shows the experiment result for H-infinity controller compared with the PD controller. The graph on the right shows that the AMB current were significantly reduced compared with the PD controller. The H-infinity controller caused a slight increase in vibration of the rotor, which is an unavoidable side effect of the reduction in current level. However, the peak rotor displacement remained quite small, less than 70 microns, and so the results are acceptable in terms of vibration and stability of the operation. The time domain measurement of the AMB current were transformed to the frequency domain by discrete Fourier transform. The results show a clear reduction in amplitude of the component with frequency at 1 time and 3 times rotational frequency when using the H-infinity controller. The power consumption measured by IMS current voltage meter as shown a reduction of about 40% with the H-infinity controller compared with the PD controller. Overall, the result can show that H-infinity controller perform well in terms both decrease power consumption and improve stability of the rotor gyroscopic modes. In conclusion, the controller design for AMB of 5-view energy storage system for minimizing the energy consumption and maintain stability can be achieved using frequency domain design based on H-infinity method. Stability of rotor precision and nutation was found to be a critical issue that can be addressed in the H-infinity control synthesis by using the correct dynamic model of the 5-view rotor. Weighting functions were chosen to give the H-infinity controller knock filter property that reduce AMB current component caused by motor excitation and rotor unbalance. As a result, the AMB current and power consumption were decreased significantly. In the current study, controllers were designed to work optimally only for a single fixed rotational frequency. Future work will examine gain schedule H-infinity controller design so that the optimal control can be varied continuously to match the 5-view rotational speed. All of that brings to the end of presentation. Thanks for your attention. Anyone have any question?
Thanks, Hong Pan. Interesting. So, any questions, please?
Yes, I have a question that whether it is implemented in the industrial application till date.
Good one. So, have you implemented this already, Hong Pan? It's still experimental, I imagine. So the question whether it has been already implemented or where he sees the applications.
The experiment that we testing with the frequency response to with the prototype system and get the result to analyze in the frequency domain with using the Fourier transform. to get the result, we can see the power consumption of this is reduced to 40%.
Okay, so the question is, have you implemented this in a real system yet, or still experimental?
Sorry?
Still experimental in the lab, right? Okay.
Yes.
All right. Okay, no problem. So how you sort of linearized the system, right? You use the linear system for analysis.
Yes.
Okay. How do you justify this? I mean, why didn't you use nonlinear system to reflect the truth? Yeah, because you just used like one velocity, one frequency? I'm just trying to understand why you decide to linearize this instead of studying a nonlinear system.
Or to reduce the uncertainty of the system when that have coupling with the X and Y direction with the model.
Yes, but okay, to linearize the system, you need to make sure it's just the variables vary within a small range, right?
Yes.
Exactly. Is this the case here?
Sorry?
Is this the case here in this application?
Oh, this application of the flywheel, right?
Yeah.
Oh, the flywheel used in the have the backup power for critical system that you see in UPS to get the power from the south and send it to the component that you want.
Okay. So I'll just any questions, please? Possibly related to control.
Okay.
Yep.
Can I ask one question?
Yes, please, of course.
Okay. Here you use PD controller and H infinity controller, right? So
yes.
Do you have any idea about zero power controller, for example?
Sorry?
Zero power controller. So in zero power controller, a current integrator is used in series with PD controller. Therefore, the power consumption is always
to reduce the power consumption of the AMB by adding the H infinity controller synthesis is just correct the model of the flywheel rotor, and it's easy to add the knock filter to reduce the current in the H infinity control and can maintain the stability at higher speed. This is a reason to choose the H infinity control.
Okay, so any more questions? Okay, I think Hompan, you pointed out that you used only one speed, and in reality, in real application, of course, the speed is going to be variable. So you did discuss that very nicely at the end. Thank you. No more questions? Because I like this research project. So, all right, so we'll move on to the next one. And this is, I think, Ms. Samia. Right?
I'm going to present.
Okay.
I'm Asha Siddiqa. I'm going to present this, and she's the corresponding author and supervise this work as well.
Okay,
so,
great.
Okay, I'm going to share my screen. Can you see my screen?
Oh, yes, we can. Yeah, clearly.
Yeah.
No.
Okay. I'm going to start. So thank you. So good afternoon, ladies and gentlemen. Today I'm gonna be talking to you about consequence of thickness variation and post-annealing ambience modification on multi-layered zinc oxide thin film. I'm Aisha Siddiqa, Scientific Officer from Bangladesh Council of Scientific and Industrial Research. So let's begin. So first, I'm gonna give you a brief overview about what I'm going to be talking to you today. So first, I'll briefly introduce about the thin film and the zinc oxide, and then I'll give you some idea about the experimental method, how is about how this work has been executed, and then I will analyze the results briefly and show you the applicability, and finally I'll try to draw some conclusion from the data we have observed. So first, a thin film is a layer of materials that has been can be ranging from fractions of nanometers to several micrometers in range in thickness, and we have chosen here the zinc oxide semiconductor just because zinc oxide is a widely studied semiconducting material, and it is still being studied because of its versatile properties. Like it has a direct wide band gap of about 3.7 electron volts, and it is commercially available, and it has high exciton binding energies, and it is very easy to synthesis. And it has also a variety of applications in optical devices, sensors, and solar cells, and piezoelectric devices. And so generally, to deposit a zinc oxide, for the zinc oxide deposition, the deposition process of the zinc oxide can be broadly divided into two parts, the chemical deposition process and the physical deposition process, and they are consist of several techniques you can see here. And here we have chosen the spin coating method. And before deposition, we have to prepare the precursor solution first. So we have chosen zinc acetate as the zinc source, and as a solvent, we have chosen 2-methoxyethanol, and as a complexing agent, we have chosen monoethylamine, and then steered for 2 hours at 60 degrees Celsius, and then spin coated onto the clean soda lime glass slides for 5, 10, and 15 times. And this 5, 10, and 15 times deposition determines the thickness of the films. And then all of the films were annealed at 500 degrees Celsius for 2 hours. And here we varied the post-annealing conditions. Here we varied the post-annealing conditions, we have parted the samples of 5, 10, and 15 times. A set of 5, 10, and 15 layers of sample were kept inside the furnace and let them to be cooled inside the furnace in the furnace atmosphere, which is a slow cooling process. And another part of these 5, 10, and 15 times 15 layered samples were taken immediately out of this furnace after annealing, and then let them to be cooled in the air environment, and we are calling them the rapidly cooled film. So all of the films were taken for characterization, and the characterization has been divided into two parts. First, I will discuss you about the effect of the thickness variation, and then I'll discuss you about the effect of the slow and rapid cooling process on the zinc oxide thin film. So first, I'll show you the thickness variation on the zinc oxide thin film. So thickness of the films were determined using the surface profilometer. And as you can see here, that with the increasing of the number of layers, the thickness is also increasing. And here the structural properties, which has been done using the XRD X-ray diffractometer, and we have I'm showing here the as deposited and annealed film. The as deposited is a pre-annealed films, and here I considered the slow cooling film as the annealed film to compare this with the as deposited films. And you can see here that it is clear from the figures that after annealing, the crystallinity of the films is improved, and also as the film thickness is increasing, the crystallinity of the annealed film is also increasing. And here is the electrical property which has been executed by the Hall effect measurement process. And I'm showing you the difference between of resistivity of the as deposited and the annual film. And after annealing, the resistivity has been increased. And you can see here that the highest resistivity has been found for the 5-layer annual film. And also you can see here that the with the increase of the layer thickness, the resistivity of the annual film is decreasing. The increase of the resistivity might be due to the prolonged cooling time can incorporate some oxygen molecules into the films, and this might be increase the resistivity of the films. And with the thickness increase of the thickness, the resistivity is also decreasing due to the better crystallinity of the film. And here is finally the optical properties of the films, and the this is the transmittance graph. And as you can see here, that after annealing, the transmittance is there is no significant change in the transmission, but with the thickness variation, the transmittance is decreasing from about 90% to 70%. So these are all about the thickness variation, and I'm now showing you the effect of the slow and rapid cooling films. Here are the structural properties of the slow and rapid cooling films, and this is evident that the rapid cooling film is showing a very degrading crystallinity of the films, and with the varying thickness, with the increasing thickness, the crystallinity is degrading gradually. And this might be due to the sudden temperature drop can affect this matter, and the sudden temperature drop has an effect in inhibition of the grain size. So this will affect the overall crystallinity. And here are some structural properties, the data relating to the structural properties. And here we can see that the crystallite size, the highest crystallite size of has been found for the 15-layered slow cooling film, and the lowest crystallite size has been found for the 5-layer rapid cooling film. And here are some electrical properties of the slow and rapid cooling films, the resistivity variation of the slow and rapid cooling films. And slow cooling films is showing the highest resistivity. The 5-layer slow cooling film has the highest resistivity, but the rapid cooling films, which is 5-layer rapid cooling films, is showing the lowest resistivity. And all the rapid cooling film is showing the low resistivity than the slow cooling film. This might be because of the generation of the zinc interstitials or the oxygen vacancies during the rapid cooling process. And this is the optical band gap is showing for the slow and rapid cooling films, and the values are 3.25 and 3.225 respectively. And the lowering band gap, the act of lowering band gap is known as the redshift. And this is the litmus test for these aggregated concentration of the oxygen vacancies. So what I have proved in my previous slide. So these are the ACM scanning electron microscope images of my films, and the slow cooling 5-layer films is showing that there are some nanofibers is developing onto the film, and this might be due to the heating effect that causes the zinc and hydroxyl atoms. They are migrates throughout the films and to ease the surface energy. And after increasing the layer thickness, and for the rapid cooling films, we do not see any kind of nanofibers, which might be due to the grain agglomeration happens at that time. And here are the AFM, atomic force microscopic images. 2D and 3D images is showing here. And from these images, we can see that some spherical part and well-defined particles and atomic force. This AFM images also gives us information about the surface roughness, and the surface roughness is also related to the crystallinity of the film, which has been found from the XRD data. And there are the slow cooling films, the 5-layer slow cooling films and the 15-layer slow cooling films, and we have found the surface roughness of the 5-layer film was 1.12. And for 15-layer slow cooling films was the 1.02, which is decreasing. And we are also seen from the XRD data that crystallinity was increasing eventually. So this is the result of the decreasing surface roughness. And also the here are the rapid cooling films. The 5-layer rapid cooling films has a surface roughness of about 0.93, and the increasing surface roughness for 15-layer rapid cooling films is 1.1. So this is also an evidence of the degrading crystallinity of the rapid cooling films. So these are the results and discussions, and the applicability of the films. All the films has been prepared so far was very highly resistive, especially the 5-layer slow cooling films. So they are very much effective for the intrinsic layer of the thin film, so for the thin film solar cell and the perovskite solar cell, because these layers needs to be very highly resistive. So this could be the applicability of these films. So I'm concluding my presentation saying that we have discussed the traits of the thicker and thinner films and the behavioral pattern in different post-handling conditions, the structural, electrical, and optical properties of them. A better crystalline quality was found for the slow cooling films. Slow cooling films were found more resistive than the rapid cooling films, and the ACM and AFM characterizations have been focused on the surface morphology and the roughness. So this is all of my presentations. Thank you.
Thank you. Magnificent. Very nice work. Okay. It seems like I have your name here listed, Samia, but is it Aisha? Aisha Siddiqa?
Yes. I'm Aisha Siddiqa.
All right. So
yeah.
So
yes, she is the corresponding author in this work and the supervisor in this work.
Thanks, Aisha. Thank you very much. Very, very nice.
Thank you very much.
Okay. So any questions, please? Any questions about annealing? So I have a question. Like, so annealing is slow cooling, isn't it?
Yes, slow cooling.
Okay, that's annealing. So that like fast cooling, then when you say fast cooling, what do you mean? Like,
well, I have said that whenever we deposit a film, we have to give them a heat treatment. So this is called annealing treatment. In the thin film process, we are calling this the annealing process. And after that, I have varied the cooling conditions. That I have just put some samples inside the furnace and let them cool inside the furnace with according to this furnace cooling system. And once another set of sample, I have just immediately pull out of the furnace after the annealing process. This is the rapid cooling films or rapid cooling process. The furnace cooling process is the slow cooling process, and the environmental cooling process was the rapid cooling process.
Okay. So when you let it cool in atmosphere, then that's rapid cooling.
Yes.
All right. Okay. But when you okay. So I thought, because there is like in material science, there is something called the quenching, which is very fast. Like you cool it from hot, red hot.
Yes.
You dip it in water type thing, cool water. So this is fast cooling. We refer to this as quenching. So I was wondering if this is yep. So just a definition more than anything. Any questions at all?
Yeah, I think the annealing is done because to have the hardness less. Because oil quenching and water quenching will impart, the faster the cooling, harder the material. Softer the cooling rate, it will be, slower the cooling rate, it will be the softer. So the basic purpose of your annealing is
to better crystallization. For annealing purpose was to have the better crystallization. Yes.
You want that stress relieving should occur.
Yes, yes.
Recrystallization. So annealing has to be done, heating has to be done above the recrystallization temperature.
I didn't get it. I'm sorry.
No. If you want crystallization, then definitely you have to heat above recrystallization temperature.
Okay, yes, it was 500 recrystallization process. It was 500 degrees Celsius for the crystallization.
Because it will be near about 0.5 to 0.8 that of the melting point of that material. Mostly, it varies.
Okay.
What is the melting point of that material?
It was very high melting point because I can mention you right now. I forgot the melting point, but it doesn't melt the sample. It will not melt, just the organized.
Obviously, the crystallization temperature will be less than that of the melting point.
Yes,
so I'm telling you the average is 0.5 to 0.8. That of the melting point will be the recrystallization. Okay. Thank you very much.
Thank you so much.
Any more questions? All right, great. So we are really on time with this session. It's still possibly 12 or 13 minutes left in the session. So the next presenter will be Badrul Haq, I think. So Mr. Badrul Haq, is Badr here at all? Badrul Haq? So Aisha, if you stop sharing, okay, magnificent. So let's see if, so this is paper number 102. Paper 102, Badr is not here, right?
Yeah,
Badr al-Haq is not here.
I
cannot, I didn't hear you say anything. So come on, have you been muted or something? Badr?
Yeah, it was muted. Can you see my slides, please?
I can see a slide. I'm not sure if this is yours.
Yes.
Okay, all right, yes.
Okay, thank you so much. I think we can start. First of all, let's, without further introduction, let's go to the business as we are running a bit of limited time. So, as you can see, the title of my paper remains Evaluation of an Energy Efficient Smart Concrete with Architectural Properties for Sustainable Green Building Technology.
Please go for the full screen mode. We are just only seeing the welcome part.
I still exactly.
Go
so
to the title. Yes.
Move to one slide to another, please, Badrul Haq.
Okay, just give me 1 minute, please.
Okay, 2 minutes, no problem.
Thank you.
All right, no problem.
Is it full now? Can you please see?
Yes, we can see, sir. No problem.
Yes, but first please show the title and then go to the next slide.
Yes, is okay. Yeah, that's cool. That's it. This is the one. Thank you, sir.
That's it.
Sir, can I please go ahead?
Yes, I thought you were ready on the go. Yep.
Thank you, sir. So the title goes like this: the evolution of energy efficient smart concrete with architectural properties for sustainable green building technology. So just I'd like to give the background of this research work that has been undertaken by me. First of all, the exponential growth of population versus rapid urbanizations, which required rapid urbanization process, thereby all the building is constructed very closely to one another, and which restricts the passing of the sunlight. As on it, proportionate lighting also plays an important role in the planning of the interior surface, and daylight technique can reduce lighting bill by about 75%, which is very significant in nature. And reduction of, obviously, it is affecting the greenhouse gas emission can be reduced at greater level, and maximum exposure of building should be made to the sunlight so that the minimum portion of the building remains within the shade, so that we can have better sunlight.
Professor Hawk, please so switch on your video also. Please. switch on your video also.
Yes. So can you see now?
Yes, we can see.
Yes.
Okay.
Yes, thank you. Thank you.
Thank you, sir. So maximum exposure of sunlight, building to the sunlight is a requirement so that we can get a maximum output out of it. And also the use of transparent brick also ensure the savings of heating and lighting costs that I have already highlighted. About 75% of lighting bill can be reduced, and energy saving materials can also play a vital role in terms of aesthetic properties. Now I'll be talking about the materials. These remain very simple for my research. This is the ordinary Portland cement, often referred as OPC, which is the Portland cement clinkers, as well as the addition of the gypsums, as well as I had the aggregates. Actually, these are the very common materials that is defined in two parts. This is particularly fine and coarse aggregates. And lastly, the waste sheet glass. This is actually we have collected from the local shops and which has been used both as fine aggregates as well as coarse aggregates. And lastly, this was fibers, which has been used for ensure that transparent concrete definition can be achieved. Actually, the passing of the lights for this fiber. And in this aspect, I have used two types of fiber in particular. This is the ordinary fibers. This is very cheaply available, as well as the filaments, which is a bit of superior in nature for ensuring the light passing capabilities from one side to other. And now I'll be talking about the methodology that has been used for my research. First, I'll be talking about the various tests that have been performed. These are the tests for transparency, as well as tests for light transmitting concrete and light intensity measurements. In my subsequent slides, I'll be covering those three parts particularly. So first, it comes about test for transparency. So in this aspect, we use the cube test for coarse aggregate. As you know, it's a basic test. It can be done by 15 centimeter by 15 centimeter and 15 centimeter of cubes. So this was one of the part, and we ensured that this test can be done according to the specification mentioned in the specified format. And test for mortar cube, this was also taken so that to get the outcome, ensuring the sustainability of the product. This I'll be talking about the test for light transmitting concrete. This is the one of the very important part that needs to be undertaken. This is the mold preparation. As you can see, few glimpses of the pictures that has been projected. So mold preparation, we have taken a size. This is 6 inch by 6 inch and 3 inch, and another mold was 6 inch by 6 inch and 6 inch. So this mold preparation was a cumbersome one also. So we took adequate measures so that we can produce the mold according to the specimen that has been narrated just now. And concrete block with single fiber, you can see few glimpses on the right sides, the few photos. So these are the, we tried to have create a concrete block with single fibers to test the transparency of the light that can be transmitted from one side to other. And we had also concrete block with bundle fibers. Actually, here we have undertaken, I have undertaken two parts. This is particularly bundle fibers without plastic pipes and with plastic pipes or the PVC pipes. So first part, this was the fiber that was collected together and inserted within the cube before casting, and the casting was done. And in the later part, we had, I had the 5 bundle fibers, which I have used the plastic tubes as well as PVC tube, so that it can have integrated, it remains integrated within the casted cube. Also, you can see few picture review of few of the efforts that has been taken by me. Lastly, we had the light intensity measurement. Actually, I have used here lux meters. This is for light understanding the light intensity and how much light was provided from the one side and how much it was the output as from other side. And test for light transmitting concrete was also performed. Now I'll be talking about few difficulty in concrete casting here. In particular, first of all, the preparation of mold. The preparation of mold, as we do with by myself. So it was a bit of challenge for preparation of the mold, as this mold need to be water sealed, and so that the curing and casting can be done very properly. Insertion of fiber in the plastic tube. This is one of the critical part because this tube is very slippery, and after ensuring that proper insertion so that the continuity can be achieved from one into other, so this need to be assured. As well as after casting, the surface of the fibers need to be cut properly so that it can give a better finishing. And as well as for this cutting purpose, I have used the scissor as well as the chisel. So as well as the workability of the water cement ratio is also important, because if water cement ratio is increased, we may achieve the workability, but it may have a flow of the concrete from the block. Whereas if the water cement ratio is reduced, then workability is also badly affected. So need to make a balance out of it. And now I'll be talking about the result. If first of all, I will be talking about the concrete that has been casted with glass concrete as well as the comparison of the normal concrete. So it does give a better output, as you can see, that has been projected with the bar charts. The compressive strength is not achieved as desired. So I have switched over to the next part. This is the mortar that has been casted using 100% glass fine aggregate, as well as another sample with 50% sand and 50% glass fine aggregate. And this gives a better output, and we could achieve a better compressive strength in this scenario. However, here the concrete was not transparent. It was projecting the opaque nature. So we have to switch now to the filament fiber. So in this aspect, we have used locally available fibers, which is having a diameter of 0.5 millimeter. And here the light source we have used so that we can get our desired outcome, that is the transparent concrete. And here the light intensity was 2400 lumen, and the spacing was varied from 7 to 14 millimeter. And the percentage of light transmitted was highest was 0.475, and it was not that much significant. Next, I have switched for the varying diameter of fibers, and again the same intensity of light used. However, the spacing was here constant. This was 7, and the light intensity increased a bit as the spacing is getting closer, and where we have received about the highest one about 0.492. However, this was not also that much significant. Now we have switched to white filament, and in this case I have used the same light intensity as well as the spacing was also varied, and we used a significant light transmissions of about highest 4.81 with the spacing of 7. My major conclusion is hereby I just like to highlight the light intensity to white filament is much more greater than the fiber that is locally available. And white filament shows greater light intensity. That is about 4.8%, which is spacing of 7 millimeter, and it decreases with the greater spacing. And strength of translucent concrete prepared for filament fiber can be used for aesthetic purpose of non-load bearing wall. There is a huge difference in strength that I have already covered about the normal concrete and the concrete made from glass. That's why we have switched to the filament. And mortar prepared with 50% of glass and 50% of sand shows a greater result in comparison to the made of 100% glass as fine aggregate. And concrete made from glass, both as coarse and fine aggregate, seems to be opaque in nature, so it fails to represent the characteristics of transparent concrete. And about the singly placed fibers that I have talked at the very beginning, it was not that significant light transmitting properties. That's why we have switched to the bundle and so on and so forth. And light intensity through white filament is much more better than light intensity through nylon fiber that is locally available. Now I'll be finishing with a few recommendations from my research. Further study should be can be carried out with the reducing time that requires for the preparation of the fiber filled tubes. And regarding water cement ratio, that it plays a vital role. So some prescribed spacing can be taken care of. And through water tubes show a better bonding characteristics within the concrete. But however, the filaments or the fiber does not show that stability that can be also taken care of. And with small spacing is difficult to maintain workability and making concrete reach everywhere, as these remain very closely spaced. So further experiment with specific A drawing should be carried out in separate blocks or panel with distinct spacing. That's come to my presentation. Now I'll be requesting the August panel if you have any question. Thank you so much.
Interesting. Okay, so that's the first time to see concrete and where people worry about the transparency. Okay, so any questions at all? Any questions?
Yes, it was a nice presentation. I have a question that how the criteria of architectural acceptance will be merged with the civil criteria. That is my question.
Yes, the mechanical property, you mean in relation to mechanical properties? Yes.
Along with the architectural requirement. Yes, please.
Yeah.
So thank you very much. Very, what should I say, very time-demanding questions that you have highlighted. Actually, here, if you consider about the architectural properties, this should be taken care of. That I try to get from my research. I could understand that it can be used at non-load-bearing wall, because if the fiber is used, we are not going to get that much of architectural properties to use in load-bearing capabilities. So aesthetic point of view, it can be used in some of the portions of the buildings so that we can get the green technology incorporated there, which will have some effect in reduction of our building systems. But from engineering point of view, if you like to use in some other aspects, we require further research that will use required dimensions or required building specification codes that will be supporting.
Yeah, I think it's not meant for structural applications, it seems. So is this part of like a PhD project or something, or you're like an innovation thing, like?
Sir, actually, this source of research has been also carried out previously by, but in our case, we have tried to incorporate a system which will reduce the cost. From economical point of view, we try to give maximum emphasis. That's why from the very beginning, we are starting from using the local fibers, then switching of the filament, which is a bit costly. So
I'm just thinking about asking about the idea in relation to innovation. Is it like part of a doctorate research project, or like sort of like innovation by a company or some commercial thing?
No, sir. Sir, this is undergraduate level at BSc engineering level. I did this research.
Okay, all right. Okay. So when you, in relation to application, which parts of the building you think this should be fitted? Just out of curiosity.
Sir, right, sir. So thank you very much. Sir, actually, this can be used on the exterior side of the building. That's why if sunlight is coming from one side, that's why the building will be outer surface of the system, so that it can comes direct contact under the sun. So the maximum sun can be utilized. And not only in the building, from aesthetic point of view, some of the outdoor facilities may be also, we can incorporate it to have some aesthetical view.
Yes, I imagine so. To replace, like instead of glass, like glass walls and stuff like that, you can use this, possibly.
Sir, glass wall is very yes. Glass wall will give very transparency, but here we'll get a less transparency. But the aesthetic part of the concept will be much more elaborated than that of those.
Absolutely,
and it should give a better look.
Yep, it makes sense. Yep. Any questions? Any more questions? Interesting. Good luck with that. Thank you.
Sir, thank you so much, sir.
All right. Okay. Thanks everyone for attending this interesting presentations. And I think this will conclude our session. We are possibly 5 minutes later than we should type things. So instead of 6, now say 6:05. Okay. So good luck everyone, and see you later on. Thank you.
Thank you. Very well session. Very well chaired session.
Thank you. Nice question. Thanks for your contribution. Thank you, Atakon. Thank you, sir. All right. Bye, everyone.
Thank you, Professor.
Bye.
Bye. Bye.
Thank you, sir.